Hey there, Algebra 2 students, Mr. Weber here. Today, you are excited, we get to practice. So there's nothing new I'm showing you today. This is just going to be a day to practice and make sure that you feel confident in the fundamental counting principle and probability from last week. So if you have any questions at all, please refer back to those videos that we posted last week, as well as your textbook. Okay, so you will need a calculator today, so if you don't have one already, go ahead and pause this video, go grab one, and I'll meet you back here in like 2 seconds. Okay, so here we go. So all you have today is an assignment. So I'm going to pick some selected problems. I'm not going to do every single one. I'm going to leave you some to do on your own, but I'll just kind of bounce around and pick and choose. Okay, so let's start with number 1. A bank requires that its customers create a PIN to access their account. The PIN must be 2 letters followed by 2 numbers. How many unique PINs are there? This is straight up fundamental counting principle. How do we figure out the total number of ways something can happen? All right, so what we need to think about first is what do we need? What are we going to choose from? All right, so well, we're going to choose 4 things. We have to have 2 letters followed by 2 numbers. So that's a total of 4 different items we have to choose. Okay, so when we have to choose our 2 letters, we have to think about first, how many options are there? So how many letters are there for us to choose from? They're not specific here about uppercase or lowercase. Let's just assume 26 letters in the alphabet. Okay, so we'll say 26. If you chose 52 for uppercase and lowercase, I get it. And because it's not clear, personally, I would count both of them. But let's go with just 26 letters in the alphabet. So we have 26 for each of those 2 slots. Now the next thing we have to do is put in 2 numbers. So how many different numbers do we have to choose from? We have 10 numbers, 1 through 9 and 0. Okay, so these next 2 options, we're going to have 10 numbers. And now what do we do? To find the total number of options, we just multiply these 4 things together. So grab your calculator, 26 times 26 times 10 times 10. It's going to be a big number, 67,600. And that's it. All we do with the fundamental counting principle is we lay out our number of options for each thing we have to choose and then multiply them together. And then we're done. Okay, look at number 2. A clothing store employee is dressing a mannequin in shoes, pants, and a sweater. There's 6 pairs of shoes, 4 types of pants, and 8 sweaters to choose from. How many different outfits for the mannequin are possible? Okay, so we have to start by thinking about what are we going to choose. All right, we're going to choose 3 things. We're going to choose a pair of shoes, we're going to choose a pair of pants, and we're going to choose a sweater. All right, so that's the first thing you do. What is it you have to choose? Next, how many options do you have? Well, there's 6 pairs of shoes. This is going straight from the problem. I have 4 pairs of pants I can choose from. I have 8 possible sweaters. 6, 4, 8. All right, so all we got to do is multiply these things together. 6 times 4 times 8 equals 192 different outfits that we could possibly dress our mannequin in. Okay, lay out your options, multiply them together, done and done. Look at number 3. How many ways can first, second, and third place be awarded to 15 contestants in a science fair? All right, this one's going to be slightly different. Let's see if you can figure it out. All right, so first off, what are you going to choose? Well, you're going to choose first place, second place, and third place. All right, so now we got to think about how many people, how many choices do we have? So when we award that first place award, there are 15 contestants in the science fair, so there are 15 different people that could win first place. Okay, but no one ever wins first place and second place. You only win one award. So if we choose, whoever we choose for that first place award, they can't win second place. So how many different options of people do we have to award second place to? Well, now we only have 14 people because one person already won first place. All right, take that same idea. How many different people do we have to award third place to? It's going to be only 13 because somebody had to win first place and somebody had to win second place, meaning there's only 13 people left who could possibly win third place. Okay, multiply those things together, 15 times 14 times 13. Beep, boop, 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 beep, boop, boop, boop. 2,730. Are we good? I hope so. All right, I'm going to jump around. I'm going to skip ahead to number 6. Travel agent is offering a vacation package. Travelers choose a type of tour, a meal plan, and a hotel class from the table to the right. How many different vacation packages are offered? Okay, so what are you going to choose? You're going to choose a tour. You're going to choose a meal. You're going to choose a hotel. How many different tours do you have to choose from? Add straight down, 3 different options. How many different meals do you have to choose from? 2 different options. And then how many different hotels do you have to choose from? 4 different options. Although honestly, who's going to choose a 1-star hotel? I don't know. But you have 4 different options. 3, 2 times 4, multiply those things together. 3 times 2 times 4 means that there is 24 different vacation packages that are offered. Does that make sense? 3, 2 times 4. Okay, number 7. Student government is making banners to advertise Spirit Week. Each banner will be made using 1 sheet of poster paper, 2 different colors of paint, and 2 different colors of glitter. They have 5 colors of poster paper, 8 colors of paint, and 6 colors of glitter to choose from. How many different posters can be made? This one's a little complicated, so let's think about this one. All right, so of all that we've done, this is the one that's the most thinking involved. All right, so what are we going to choose? All right, we're going to choose 1 sheet of poster paper. Poster paper. Say that 10 times fast. All right, what's the next thing we're going to choose? 2 different colors of paint. So I labeled it paint 1 and paint 2. 2 different colors of glitter. Glitter 1 and glitter 2. So a banner is going to be made, we're not just choosing 1 of each like we did before. We're going to choose 2 paints and we're going to choose 2 glitters. And what's important is that it says we're choosing 2 different colors of paint and 2 different colors of glitter. All right, so now we can think about our options. How many colors of paper do we have? 5 colors of paper to choose from. How many colors of paint to choose from? All right, we have 8 colors of paint. So when we choose our first paint, we have 8 options we can choose from. But what did the question say? It said that we have to have 2 different colors of paint. So whatever paint color we chose first, we can't choose again. So now we only have 7 different options to choose from. Does that make sense? Okay, look at glitters. How many different glitters do you have to choose from? There are 6 different colors of glitter to choose from. All right, but again, once you choose that first color of glitter, you can't choose it again because they want you to choose 2 different colors of glitter. So how many different options do you have for the second color of glitter? Only 5. Okay, now, how do we find the total number of options? We do what we've always done. We multiply these things together. Grab your calculator. 5 times 8 times 7 times 6 times 5. What is that? 8,400. 8,400 different posters can be made. Okay, does that make sense? I sure hope so. Here we go. Let's switch gears and talk about probability. All right, so remember when we talk about all probability, it is the number of favorable outcomes over the total number of outcomes. So number 11 says that a cooler contains 18 canned drinks, 9 lemonade, 3 iced tea, and 6 cola. D selects a can without looking. What is the probability that D selects iced tea or lemonade? Okay, so here we go. Probability is always favorable over total. So how many total drinks are there? 18 canned drinks. So that's our denominator. We're looking for the probability that she selects iced tea or lemonade. So that's going to be 9 plus 3 on the top, iced tea or lemonade, 18 on the bottom. So that's 12 over 18. Can we simplify that? Yes, 2 over 3. Remember, anytime you can simplify, you need to simplify. So we can divide the top and the bottom by 6, and we'll get 2 over 3. Okay, number 12. Sam has 9 pens in her pencil pouch. 2 are out of ink. If she randomly selects a pen from the pouch, what is the probability that it is out of ink? Okay, so remember, probability is the number of favorable outcomes over the total outcomes. All right, so how many total pens are in her pouch? 9. So that's the denominator. Okay, so how many pens are out of ink? We want to know the probability that her pen is out of ink. Well, there are 2 pens that are out of ink. That's the numerator. Okay, so 2 over 9. Done and done. Can't simplify it. Done and done. Okay. All right, you can see I messed up my animations here, but that's okay. Probability is always the number of favorable outcomes over the total outcomes. Okay, so how many total marbles are there? It says a bag of marble contains 9 yellow marbles, 6 red marbles, 5 green marbles, and 4 blue marbles. What is the probability that a randomly chosen marble is not blue? Okay, so this is a great question. So if I add that up, 9 plus 6 plus 5 plus 4, I see there are 24 total marbles. All right, so that's my denominator. Now, what's the probability that they are not blue? There's a couple different ways I could do this. I could go through and just start adding all of the marbles that are not blue, okay? Or I can remember my complement formula, which remembers the probability that it's not blue is equal to everything, 1, minus the probability that it is blue, okay? Sometimes that's an easier way to think about it. So what's the probability that it is blue? Well, there's only 4 marbles. All right, so I have 1 minus 4 over 24. 4 marbles are blue. There's 24 total marbles in the bag. Okay, now, can we simplify? Yes, 4 over 24, divide them both by 4. 4 goes into 24 6 times, so that's 1 over 6. Now remember, when we subtract, 1 is like a wild card. I can turn 1 into anything I want. To be able to subtract 1/6, the denominator needs to be 6. So I'm going to change 1 to 6 over 6. Does that make sense? 6 divided by 6 is still 1. I'm not changing the value. I'm just changing the way that it looks so that I can do the subtraction. Now that I have the same denominator on the top and bottom, 6 minus 1, my answer is 5 over 6. That's the probability that I select a marble that is not blue. Does that make sense? Okay, those 3 examples were examples of what we call theoretical probability. The probability based on what should happen. We know the total, we know the number of favorable outcomes. We don't have to actually select this to figure out what that probability is. Okay, let's talk about an example of experimental probability. Okay, so first off, read the directions. All right, so if you just look at this and you think about this as regular probability, you might think that I have 4 numbers, so I have a 1 out of 4 chance of spinning each of these numbers. All right, but see, here's the thing. We don't know what this spinner looks like. All right, let me show you an example. All right, it's possible that our spinner looks like this. One, two, three, 4. 4 equal sections, right? That's possible. But no one says that each section has to be the same size. So it's possible that we have 1, 2, 3, 4. It's possible that we have 1, 2, 3, 4. Who knows what this spinner looks like? It could look like anything. Okay, the key is we don't know what the spinner looks like, so without seeing a picture of the spinner to know, we can't think about this as theoretical probability. There's no way for us to figure out what this probability is without doing an actual experiment. And if you look at the directions, they tell you that's exactly what they did. Okay, they tell you that the table shows the results of a spinner experiment. Use the table to find the experimental probability. Here's a big old hint. If they ever give you a table, they want you to use it. 9 times out of 10, they want you to use it. Okay, now I'm not going to do all 5 of these problems. I'm just going to do 16, 17, and 18. I'm going to leave 19 and 20 for you guys to do on your own. All right, so let's look at number 16. What's the probability of spinning a 3? Well, the first thing we need to do is figure out how many total spins there were. So take the spins. So we look at our table. The top is the number. The bottom is the number of times that we spun. Or I'm sorry, how many times it landed on that number. So add up that bottom row and really quick figure out how many times did we spin this in total. So add straight across 15 plus 10 plus 8 plus 22 equals 55. It means we spun this 55 times. What it means is probability is favorable results over total. We spun a total of 55 times. So 55 is going to be our denominator. Okay? All right, 16. What's the probability of spinning a 3? Well, how many times did we spin a 3? We spun a 3 8 times. So guess what our probability is? 8 over 55. Done and done. Is that really easy? Really, Mr. Weber? It's really that easy? Yes, it's really that easy. You guys can do this. All right, look at 17. What's the probability of spinning an even number? So look at your numbers. Which one of those are even? 2 is even and 4 is even. Okay, how many times did you spin a 2 or a 4? 10 plus 22 is 32 over 55. I still spun a total of 55 times. Done and done. Ask yourself if you can simplify that. Hint, 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 you can't. So you're good. Look at 18. Probability of spinning a 1 or a 2. All right, so now we're going to look at 1 or 2. We spun a 1 15 times. We spun a 2 10 times. So we spun a 1 or a 2, a total of 15 plus 10, which is 25 times. So this probability is going to be 25 over 55. And this one we can simplify. We just divide the top and the bottom by 5. And our answer is 5 over 11. That's it. Do you think you can do it? I hope you can. If you have any questions at all, please don't hesitate to continue to reach out to your teacher. We are here to help you out. You guys are doing great. Just keep doing what you're doing. Until next time, see ya.